Hi, this is Andrea Atkins from Architectural Engineering at the University of Waterloo, and I'm going to share with you a little bit about our program and what makes it awesome. So the things I want to cover in this presentation are here on this agenda slide. We're going to talk a little bit high level about the program. We're going to talk about the way that we teach at Waterloo, which is very much experiential learning. All the resources that you have available to you when you join us in September at Waterloo in our department, all of the expectations of our co-op system, which is actually a really, really special aspect about doing engineering at Waterloo. We'll talk a little bit about some student experiences, and then I've got a problem for you at the end, which might just pique your interest in why you'd love to join us in the fall. So a program overview. So if you're interested in architectural engineering, that probably means you're interested in the design and construction of the built environment. So that might be buildings or bridges or public spaces. It might be a giant suspension bridge. It might be a tunnel. Any of these spaces that people occupy and how we love living there, that's architectural engineering. So in our program, we're going to cover the design and also how it goes together, but we're also going to talk about assessment and repair and refurbishment of the building stock that we already have. Because we all recognize there is a climate crisis, we need to figure out how our buildings that we have that were built 50 to 100 to more than that years ago are going to move forward into the future without just demolishing them and sending the waste to the landfill. So we're going to talk about what we can do to keep our buildings going and make them better for future generations. And of course, not every building is an old building being refurbished. We're also going to talk about new buildings and new technology, things that are emerging, green buildings, sustainable building technologies. We're going to be keeping you up to speed, up to pace with where things are going in the future as far as sustainability goes. So our program is a 5-year program. So you've got 4 academic years in 5 consecutive calendar years, which can be a bit overwhelming when you think about it at first. So here you've got 5 years laid out in a calendar, and you're able to see what happens in each term. So those yellow terms are your co-op terms. So you can see you've got 6 opportunities there. We require you to complete 5 of them. So if you don't get a co-op job, it's not the end of the world. Or if you want to go travel or you want to go do some cool research, not the end of the world. You have opportunities to chase your dreams and figure out what you want to do with your engineering degree on those yellow co-op terms. Outside of those co-op terms, you'll see that we alternate every 4 months. So fall is September till December, winter is January till April, spring is May till August. And so you'll see every 4 months you're going to go transition from school to work and school to work back and forth. And while you're at school, you're going to do some classes that are lecture-based, some classes that are studio-based. And so you'll see the lecture-based classes, or sometimes they're labs as well, are shown in purple. And those are our core courses. So all of your AE counterparts, all of your friends are all in those courses together. The blue ones are the ones that really separate us from the other engineering programs, even on campus. And those are our studios. So we have mandatory design studio courses in our own design studio space on campus. So every architectural engineering student is guaranteed a desk in a space with their peers so that they can work on their projects all together and push the design thinking that much further. So every term we're going to be working on projects together in studio, and that's shown here in light blue. As you see, when you move forward towards year 5, you are getting into a lot more of those orange boxes. So those are your electives. Some of them are complementary studies. So they might be a philosophy course, an English course, a history course. It might be language, whatever you're interested in. And those technical electives are the ones labeled TE. And those are the ones where you start to specialize. And we're going to talk a little bit more about specializations in a bit. But those are the ones where you might take a lot more about structural engineering or a lot more about environmental engineering. And you can really tweak your architectural engineering degree to be what it is that you want it to be. So our specializations that come out of the architectural engineering program are building structures and building systems. So building structures is the structure that supports a building or a bridge. We're going to include some bridge work in our courses as well. But mostly it's about the skeleton that puts together and supports all of the architecture that goes on in a building. Building systems could include anything about how the building works and keeps itself warm and dry inside, so your HVAC system, or it could include something like a photovoltaic system or a wind power generating system. We're talking about the new ways that we might be coming across energy for our buildings. But also building systems will include building science, which is sometimes called enclosure design or building envelope. And that's the part of the building that keeps the outside out and the inside in. So everything from that last coat of paint to the farthest edge of the surface of the brick on the outside of your house, all of that would be included in your building system specialization. On top of that, we've got some unique opportunities in all your engineering programs. You've got different options. So these could be from AI all the way down to statistics or environmental engineering. If you take a number of courses in any one of these specific divisions, you're going to get a little bit more specialized in any of those things. So you might have an architectural engineering degree that has interest in international studies, but your colleague might have an architectural engineering degree with an interest in mechatronics. So they might be talking about robots, and you might be talking about policy and how we're going to come up with a solution to a global energy crisis. So you can see how, even though you might all be in the same course, the options and the specializations give opportunity for everybody to kind of craft their own engineering degree. So what you can expect in your first year at Waterloo Engineering, in architectural engineering, you're going to see about 20 to 25 hours of in-class time. So that might be a lecture, it might be a seminar, it might be a tutorial, you might be seeing your TAs or you might be seeing your prof, but I'd be expecting 20 to 25 hours of that. On top of that, we'll expect that you're doing about 20 to 25 hours of study time per week if you're an average student. And that is throughout the term. Sometimes at midterm time, you might be doing more, and sometimes when things are not super busy, you might be doing less. It's an average. And what makes us special is that studio course. So you might have 16 hours of lecture time where you're sitting and taking notes diligently, but of that 20 to 25 in-class hours, about 5 of those hours are going to be in studio, where you're working, where you're dialoguing with your professors, where you're meeting with your TAs and you're discussing solutions to real-world problems with your peers and with your teaching team. So it's a real interactive place and an interactive way to teach. And some terms, depending on what courses you're taking, you could have 9 to 12 hours of lab time throughout the course of a term, and it depends on the term. Sometimes those labs are in water, sometimes those labs are in structures or materials. We've got a number of really cool labs on campus, so if you get an opportunity to check them out, it could really be that thing that pushes you over the edge and makes you want to join us at Waterloo. Some of the things that really separate architectural engineering from the rest of the programs at Waterloo, but also Waterloo from the rest of the programs that you have available to you in Canada, are that we have design studio. I can't stress this enough. It is both a sweet place to work, and it's also the same, we use the same word to describe our core teaching method. So we're going to be using projects, and they're going to be in collaboration with your other lectures that term. So you might be learning about thermodynamics in one lecture, and then later on that week, you might be designing using thermodynamics, and you might be thinking about how you could solve a thermodynamics problem with respect to keeping the heat in the building in the middle of the winter. So we're going to be coming up with applications that are directly applicable to your lecture time and your lecture courses each time in your studio courses. Something that's particularly cool about our architectural engineering and what differentiates us from a lot of the other engineering courses on campus is that in your third year, you get to go and you spend 2 terms with the School of Architecture in Cambridge. So our School of Architecture is award-winning. It's right on the banks of the Grand River in downtown Cambridge, and you will be rubbing shoulders with those architecture students. So we're going to have engineers and architects right in the same building, and we're going to be solving problems together. And there's no better way to creatively solve problems than to bring together people who have different ways of solving problems and different ways of thinking. So this is going to be a really exciting way to practice your communication skills and practice problem solving with people who think way outside of the box. So that focus on communication is something that architectural engineering and studio in particular is really, really pushing at Waterloo. We want to make sure that you are confident in writing, in graphic communications, that might be sketching or 3D modeling, and we want to make sure that you can give an oral presentation. Because you could have the best idea in the world, but if you can't communicate it to your client, it might never get built. So we want to make sure that we are enabling you right from first year to being great at presentations, at written reports, at sketching your ideas, and making sure that you have these skills so that when you go for that co-op job 4 months out of school, you're going to be able to say, hey, don't worry, I know how to work in a team and I know how to communicate my ideas. So after graduation, fast forward 5 years, and you are looking at a career in the global building sector. So you are not limited to just working in Canada or even North America. We've got positions all over the world, which would be just right for our architectural engineering graduates. So you could kind of end up in 3 different roles. You might be consulting, you might be working on fabrication or construction, and you might be a representative of a building or a bridge. So our consulting roles, you might be a structural engineer, you might be an accessibility consultant, you might be a sustainability consultant. For fabrication, you might be working for a contractor or working on a construction site, supervising or inspecting what's happening there. You might also be designing new materials or products or testing them and coming up with the future of cladding. Who knows? Right now it's brick. Maybe in 20 years it's going to be a product that you design. And also, we like to think that we could represent our buildings because of those communication skills that we have. Because our old buildings aren't able to speak for themselves, we often have people who are either trained as architects or engineers, or in our case, architectural engineers, to speak for our buildings. So that means you might be working for a municipality, so that's a city, reviewing department issues. You might be going and reviewing buildings, you might be looking at plans, you might be making sure that everybody is following the building code and following the local bylaws, because you will know about buildings, and you will make sure that people are safe in the buildings that get built within your municipality. There also are often people with these roles at institutions. So large hospitals or universities like the University of Waterloo have somebody on campus who represents the capital projects. When a new building gets built on campus, there is a representative of the University of Waterloo who gets to call the shots and make sure that what happens on campus is up to snuff. I could definitely see a lot of architectural engineering graduates being outstanding at those types of positions. And of course, if you don't go right off into your career after your undergrad, you could head over into graduate studies. Now, at Waterloo or otherwise, there will be MASC, which are Masters of Applied Science, or PhD programs in civil engineering available to you. And I could also see that you might want to go over into a Masters of Architecture program, and there are some programs within Canada who would accept graduates of our architectural engineering program. And the research that you might be interested in, if you're interested in architectural engineering, would be something like material science, new low energy building systems, fabrication methods, design for reuse. How do we come up with a building that can be used not just for what we ask it to be used for today, but 50 years from now when we no longer need a library, what are we going to do with that space? How do you design a building so that way it could adapt and become an auto mechanic shop for cool electric cars, or where all the robots live? Who knows what the future is going to hold? So we want to design buildings that can adapt to the future. So Waterloo's main big ticket item is that we make sure that you are learning from day one. So we're going to talk about experiential learning now. So our AE program has the benefit of having kind of built-in experiential learning possibilities. So for all of our project-based learning that we do in studio, we're usually modeling these things and testing them. So that means you might build, as you see in the lower photo here, you might build a bridge out of popsicle sticks, and you might build some kind of cool, beautiful building. And we want to make sure that we can represent what it looks like at a scale where you don't have to pay out the nose and build the entire building. So we build a small model of it. But what makes us engineers and not just architects is that we want to test them. So we're going to take that popsicle stick bridge and we're going to load it up with a bunch of weights, and we're going to see how much load it can carry. And this design and testing method is very common in engineering practice, and we're going to make sure that you experience that all through your undergrad degree. We also have the opportunity to participate. Well, students have the opportunity to participate in our design teams. So these are industry-funded clubs. So they're not through our program, but we've found that our students are particularly interested in the clubs which participate in Habitat for Humanity builds. We've got a Waterloo chapter, and we also have participated in a solar decathlon project, which is pretty neat. It's a great competition. It's available worldwide, and you build a small building. You design a small building, and then you have to build the small building, and that is when you get to participate in a solar decathlon, where they give you 10 different challenges, and you have to make sure that those 10 challenges are all met by your little building. It's a pretty neat challenge, and it's worth looking up right now. We also have our design days. So this is something that the University of Waterloo is really interested in, and our architectural engineering design days is an opportunity to design and construct furniture. So we don't just give students wood and leather and typical furniture opportunities. We say, hey, here's some cardboard and here's some concrete. Design something and now build it. So our students in the first week of classes are given the opportunity to look at a space, conceive of a type of furniture that might be needed in that space, sketch it out, decide how much material they're going to use, because the material is not infinite. They actually have a budget of how much material they can use. Then they design it, then they must fabricate it, and of course, we're going to load test it. And in the past, we've taken these benches and chairs and tables out to the yard with lots of sandbags and just piled on the sandbags until the furniture can't take it anymore. And somehow, some chairs were able to hold up all of our sandbags, 20 massive sandbags. So we've got some outstanding engineers in our midst. So our 4 programs within the Department of Civil and Environmental Engineering are shown here on this slide. So you've got civil, you've got geological, you've got environmental, and there's us, architectural engineering, up in the upper left quadrant. And you can see that we all overlap at the hub, which is sustainability. We are all here caring about our environment and making sure that it stays in a shape that allows us to continue to live as a civilization, continue to succeed as our community, and hopefully thrive going forward into the future. So our architectural engineering quadrant, as you can see there, we overlap with civil in that we both teach structural engineering. We're more focused on buildings and how it works, how structural engineering applies to buildings. And we're also overlap with air quality with environmental engineering. We care mostly about indoor air quality, but they consider indoor and outdoor air quality in their studies. So our little quadrant up there, you can see we're talking about building science and systems. So again, building science is what keeps the outside out and the inside in. And we're also concerned about the technological aspects of architectural design. So an architect might sketch a napkin sketch, but we need to be able to make it work and make it last. And of course, there's that communication collaboration part, which is listed there as architectural project management. So we want to make sure that we can go from a cool idea to amazing drawings to a built building without any hiccups all the way along the way. And here's a hint, communication is what's going to get you there. So our department resources are available to all of our students, undergraduate and graduate, and we want to make sure that you know they're available to you because they're designed to help you succeed. We're not going to let you in and then let you fall. We want to make sure that you know that you are supported. So our team includes all kinds of award-winning instructors, amazing staff, and technicians. We've got a whole group of people at CEE who are going to be able to connect you with industry for those co-op jobs and be able to give you information about their lived and worked experience. Especially for first years, we have an entire program to make sure that you are learning about studying styles because maybe you haven't come across something that's quite like Waterloo engineering before, and we don't want you to fall behind. So we enable our students to learn about problem solving and time management. That's a really big one. If you want to succeed, you'll have to figure out how to get that sweet work-life balance. And of course, prioritizing what to do and exam preparation. We make sure that our students have not just the knowledge, but also the skills in order to succeed in engineering. So those were our staff support system, our faculty support system, but this is our student support system. So we have some award-winning student societies, including a student society that's just for our civil, environmental, architectural, and geological students. But also there's a engineering-wide society called the Engineering Society, and these are all students student run, student focused, for students, by students. And so they do things that are fun, and they organize all kinds of events to really achieve that work-life balance. But at the same time, they also make sure that our students are succeeding. They're not just there for fun. They do provide resume critiques for those first co-op jobs when you just are figuring out what's going to look good on the resume. They bring in people for guest lectures. That way you can network with people in engineering or other similar fields. They also regularly organize tours of neat facilities, especially for us architectural engineers. We might be interested in seeing a construction site. So they offer us that opportunity. And they also make sure that our students are looking after themselves and are cared for. So we've got a wellness and diversity promotion team on multiple of our societies to make sure that students are getting that well-rounded experience, and you're not just totally lost hitting the books, that you are making friends and connecting and making sure that everybody is on the right track. So what separates Waterloo from everybody else? It's those co-op terms. So let's talk about co-op. So you're going to work through 5 years. Again, there's a different version of that calendar here. And you can see that we're going to be switching back and forth in AE every 4 months from school to work to school to work. There is one hiccup in this back and forth, and that is in your 4th consecutive calendar year, where you will see 2 academic terms back to back. This is a bit of a change in the system that you might have gotten used to by your 4th year in engineering, but it really opens up the opportunity for you to work on a project for 8 months straight. Instead of just doing 4 months of school, you can really dig in and exceed your expectations by having double the amount of school back to back. It also allows you to finish on at the same time as all of your other engineering colleagues, so everybody gets out at the end of April every year, and so there's all the 4th year celebrations that happen between all types of engineering disciplines, and it's really beautiful to see. So as you're working your way through your terms, you'll see that you are starting out at about $18 an hour, and the average wage could be up to $26 an hour. Now, that's just the averages from 2019. Who knows what you might be making by the time you get there to that last co-op term. It's definitely not minimum wage, and it's going to go a long way towards paying off your tuition, paying for your rent, and making sure that your student debt is as low as possible. And that is one of the best parts of our co-op. And if that wasn't enough, you're also getting real work experience. And that work experience, as you can see on this slide, can count for a year of your necessary 4 years of experience to get licensed as an engineer in Ontario. So the professional engineers of Ontario, in order to get licensed, you need to have 4 years of work experience. Well, if you've already done all of your co-op terms at Waterloo, that could count as 1 year of experience. So that gets you so much more of a head start. So the jobs you might be working on, here are some students who I'm actually teaching this term, and they're working in research, they're working in product manufacturing and product design, they're working on construction sites. Some of them are consulting, not in any of these images, but you know that you'll see from later slides that there are students who end up working in consulting. So they might be contributing information to architects to design buildings or to design bridges. We also have some public sector work, so that's that municipality work. So you might be working for a city, or you might be working even for the federal government. And there's always opportunity for research. So it might be on our campus, or it might be somewhere else. So you could be working for the government doing research on new products, new energy systems, and ways of modifying policy or standards or codes in order to make the future that much brighter. So some of the jobs that our students have had are listed here. They've had consulting firm jobs, so often those are either structural jobs or actually architectural design jobs. We've had students contribute to architecture firms for the last couple of years, and there's nothing that stops you from going after those jobs. So if you're interested in architectural design, that's an opportunity for your co-op time. We've also had students work in building performance, so that might be our building science experts, and you'll see a little clip of a student who participated in that. And they also, some of them worked for construction companies or regulatory agencies, so those would be the testing agencies and the cities and the building inspectors, but also building owners and operators. So those are the people who want to know, hey, I own this building, I want to make sure that it's going to last another 25 years. What kind of maintenance do I need to do in order to make sure that this building does not fall apart before that 25 years is up? And so our students have been getting out there and participating in this kind of work, and it's been thus far a great learning experience. So how to get your first job? We know it's not easy, and so you can start thinking about this now. And I recommend that if you have a part-time or a summer job, that is a great experience in order to build up your teamwork, your communication, your collaboration skills. If you have, it's true as well, if you have extracurricular or volunteering experience, if you like to participate, I don't care if it's cleaning horse stalls or helping at the veterinary clinic or teaching kids dance or anything really. If you are participating in collaborative work and you're working as a team and you're showing up on time and you're there to help out when you need to help out, that is already amazing experience towards becoming an excellent employee. And I've added here that if you have the opportunity, I recommend that you sketch or draw or photograph buildings. Because if you're going to be joining us in the fall, you're interested in buildings. So you can start thinking about, hey, how does that wall connect to the roof? How does the water get off of that roof and down into that gutter? Start looking at it and thinking about it and trying to interpret the way that buildings work. That's something that you could do right now. And how are we going to make sure that you get that first co-op job, and we're going to make sure that you're enabled in your first year of school? We make sure that we develop the skills of drafting and sketching. So you can see in the picture here, the student is practicing drafting. And we're also going to enable you not just with manual methods, but digital methods. So we're going to make sure that you know AutoCAD and Rhino, which are a 2D and a 3D modeling software. And we're going to make sure that you know how to read building drawings, because it's very rare that somebody just stands on a construction site and says, move this there, now put this over there, now make that one this size. We typically issue large format drawings, and that is how the building gets built. You have to be able to read drawings to build a building, and you have to be able to draw drawings to design a building. And the last one there is those communication and collaboration skills. You're going to be giving presentations, you're going to be doing group work, you're going to be making sure that you are able to sell yourself in that first interview. So you are confident talking in front of people. We're going to make sure that we all get there together. So what's our student experience like at Waterloo? So Waterloo has a number of student clubs and societies. So these are not specific to engineering. These are all across. So you can go and meet people in arts or in science or in math, and it's a great opportunity to mingle and get that work-life balance. So we have student events that are run. The one in particular here that's highlighted is Engineering Day. Engineers are a proud bunch, and we want to make sure everybody knows that we have a good time. So that tends to be a really fun event for everybody. You also have opportunities to get involved and keep your physical well-being up to snuff. There are intramurals and tournaments, so you can join a dodgeball team or a stick hockey game, or you can play basketball or join a volleyball team. You don't have to take it that seriously. Or if you want to take it seriously, we've got varsity teams for you. So you can come and try out and join a varsity team and really compete and represent Waterloo against everybody else. We'd love to have you. And of course, if you're just there for the dancer size, then we've got fitness classes as well. So I'm sure that there's something for everybody in our recreation center. And the last thing you want to worry about, because you've got so many things on your mind right now, is where am I going to live in September? I really want to go to Waterloo, but I'm not sure where I'm going to live. Don't worry, because residence is guaranteed for our first year students. We make sure that you are not adding one more level of stress to your already busy day. So we'll make sure that you have a place on campus, if you want it, where you can be very close to campus, a short walk to your classes, and be right in the same room with people who are doing the same thing as you. You want to make sure that you are not the only person studying really hard. No worries. Everybody on your floor is studying really hard for midterms, so you can all pull together. So here's a little brief by my student Jawad, and he is currently in 2A, so that means he's in the first half of his second year. And he's worked 2 terms at RDH, which is a building science firm. So this is that consulting experience that I was telling you about earlier. So he worked for 2 terms at the same firm, but because the firm is an international firm, the first experience was local in the Waterloo office, where he got to do some material testing and he got to do some feasibility reports. But then his second term, he worked for RDH, but in Vancouver. So he was able to go and do some research into the assessment of some university campus buildings and some BC houses. So he was able to travel and really get some diverse experience, even though he worked for the same people both times. And it looks like he wasn't always necessarily working very hard. Engineers are known to like to joke around and have a good time. And you can see there, it looks like Jawad had some fun with some balloons in the second photo. So our co-op opportunities are a bit of a breath of fresh air after you've done 4 months of school, which is very intense, but it also is an opportunity to continue learning. And I know that the more students learn on their co-ops, the more they come back and start to share really great experiences with each other. So the learning doesn't just stop at the end of a school term, it continues right into your work term, and you end up actually experiencing way more because of our co-op opportunities. So if you want to be an engineer, you need to think about design. And we don't necessarily think about design in a linear way. It's easy to think that, you come up with a problem, or you think of some people who are experiencing a problem, and you empathize with them. You think, okay, what are their issues that they're dealing with? Okay, they also have maybe some sustainability concerns, and they also have maybe a garbage dump, and okay, there are all these things, and I need to know, what is it like to be in their shoes? And then based on that experience, you can define what it is that the problem is going to be. Okay, the problem now, we decide and we pin it down, that's going to be the problem. Now, once you know the problem, you start to design the solution. You come up with ideas that's going to solve that problem. And then once you've got maybe the best idea, you decide to build a prototype, and that might be a model. So it might just be a smaller version of exactly the same thing. Or maybe you just design a prototype of one part. Maybe there's a node that's the most difficult thing to come up with a solution for. So you build a model of just a part and not the whole solution. And then you test that prototype. And when you get the results of your test, you might realize, oh, actually, this doesn't solve the problem that we set out to solve. So we need to reevaluate our problem. We need to define that problem again. Or you might find, actually, now that we've tested it, one of our other ideas might be a better solution. So you go back to the idea stage, and maybe when you build the prototype, you realize that the idea was a little bit weaker and you can make it stronger. And so there's these loops within loops that we have in our design thinking, which is really what we call an iterative project. We iterate. We go forward, we go backwards, we work our way through. And we're definitely hitting all these steps, but the path that we take to get to the end result is generally not straight, and we've generally cycled through several situations in order to get to the best solution. So I've provided you here a problem. If you're interested in architectural engineering, then this problem is probably one that interests you. So the example I'm giving you here is called an urban overbuild. So I'm asking you to come up with a solution that is a sensitive densification of a historic site. So we have a lot of places in Canada and even in the United States and all over the world where we have historic sites. We have designated buildings or parks or regions as being historically significant. But at the same time, our population is booming, and we need places for people to work and places for people to live. And so we can't have all of this low density historic fabric right in the middle of our downtown. We don't want people to have to drive to the edge of town to get to their office building. So here, I've given you a situation. You have an existing building that has been designated heritage, which means you're not allowed to knock it down, and you are not allowed to mess with it a heck of a lot. They will get mad at you if you change the look of it on the outside. And this existing building has no insulation in it. So if I'm inside the building and it's -20 outside and I put my hand on the wall, it's going to be very cold. It might not be -20, but it's definitely not 21, which I might want it to be inside. And your challenge is to add 15,000 square meters of office area to the site. So you're not allowed to mess with the building that's there too much, and you have to add a ton more office space. And because the owner is very concerned about the cost of energy, they want you to reduce the energy consumption of that original historic building by 75%. So how do we design an expansion to the structure of this original historic building? And how do we design the new facade if we're worried about energy consumption? And I've provided you here with a couple of examples in Toronto. One of them is the Queen Richmond Centre at Peter and Richmond, and one of them is 7 St. Thomas Street, both of which have original historic masonry buildings at the base and office towers above. And they have found creative ways of integrating the old and the new and without totally disrespecting the historical front that was already at the edge, already on the site. And they have found a way of coming up with a structural solution, because you can't just pile 13 stories of office on top of a heritage building without breaking it. So there's many different solutions to this. Here are a few that we've seen in the city of Toronto, but this is something that you might see in your experience in your studio courses at Waterloo. You also might see it on your co-op terms, and I expect that in the future you might see it in your career. So if you have really enjoyed and getting to know a little bit more about architectural engineering, I encourage you to go to our website and to reach out and connect with some of the people there. We'd love to hear your questions and answer them. We'd love to meet you if we've been given the opportunity. And hopefully this has taught you something, and I'd love to see you in the fall. So come on over to the University of Waterloo in Architectural Engineering. I'm Andrea, and it's been my pleasure. Hope to see you in the fall.
Hi, everyone. I'm Professor Kim. I'm here to talk to you about our civil engineering program. But I'm hoping that my presentation here will give you at least a good idea of what our program is like, and really give you a good breakdown of what life is like at Waterloo. So I'll start off with an overview of our academic program. And then I'll introduce some of our department resources we have to help you succeed here at Waterloo. And then I'll introduce our approach to experiential learning, talk about our co-op program. There's a few slides here on student experience. It'll give you a good sense of what being a student here is like. Just to introduce myself, when it comes to student life here, I feel like I have a pretty good idea. I'm a UWaterloo alumnus. I graduated from the civil engineering program in 2011. And then after completing my PhD, I joined the faculty here as an assistant professor in 2018. My main research is on the performance of structures, buildings and bridges under extreme hazards, things like earthquakes, tsunamis, hurricanes, etc., and retrofitting and strengthening these structures so they have the capacity to withstand such events. In terms of teaching, I teach linear algebra to all first-year students. So if you decide to join us here in the fall, I'll definitely be seeing you. I also teach structural dynamics to fourth-year students and earthquake engineering to at the graduate level. So these are just some pictures from my time here at Waterloo. Top left is me in first year. Top right, that's me on one of my co-op terms, me at convocation, and the bottom left picture is just me today. So let's talk about our program here. So the Department of Civil Engineering, Civil and Environmental Engineering actually consists of 4 different programs. So we have our civil engineering program, geological engineering, environmental engineering, and architectural engineering. As you can kind of see from this diagram, each program has its own unique kind of areas of specialization, but you can also see that there's considerable overlap between them. So just choosing to study civil engineering, it doesn't really limit your options. Students still have the freedom to kind of pursue different areas of interest if they would want to. Kind of at the core of our department, the unifying theme that ties all of our programs together is our commitment to sustainability. So our goal here is to develop strong, responsible engineers who have the tools and skills necessary to solve problems and make the world a better place for us and our future generations. So I'm here to just focus on the civil engineering program, and I'd like to kind of start off by saying that civil engineering is a broad field. It really is And civil engineering is all around us. So it's in civil engineers design the buildings we occupy, the roads and bridges we drive on. They take care of the water we drink, the waste we produce, and even the materials we consume. And so our program introduces our students to all of these different areas and helps them develop strong engineering fundamentals, as well as teaching them the state-of-the-art technology. So as you move through the program, you'll be able to kind of tailor your degree a little bit to a particular specialization by focusing on courses in that area. So you can choose to pursue a geotechnical option, a structural engineering option, a transportation option, or a water resources specialization. But this isn't mandatory. And instead you can choose to take a variety of different courses. So you have the tools to tackle a wide range of problems in practice. So in addition to specializations within the department and within the program, we also have options to further enrich and broaden your degree. So options are kind of like minors. And so to complete an option, you have to take additional classes outside of the civil engineering program, but you can pursue options in areas like artificial intelligence or even software engineering. So these are extra tools that you can equip yourself with to really tackle these very complex and some of the emerging problems we have in the world, like things in AI or life sciences, etc. So these, if you do complete an option, this is something that would be reflected on your diploma when you graduate. So this is an overview of our engineering curriculum. As you can see, there's a total of 8 academic terms, with 6 co-op terms kind of slotted in between. I'll talk a little bit more about the co-op terms later. So with our co-op program, it takes a minimum of 4 years and 8 months to complete the program. And an average academic term has about 5 courses. There are terms with more, but the typical term, as you can see, has 5 courses. In first and second year, students are concentrating on fundamental courses like mathematics, physics, materials, computational methods, things that really set the stage for higher level analysis and design courses, which come in third year. And so in third year, you're introduced to the introductory design classes, and this is when you start working toward your specialization if you choose to do so. So specializations, this is how you would do that, is through technical electives, TEs. And in third year, you also have what are called complementary studies electives to get you to explore courses that are outside of the engineering curriculum as well. And then by the time you're in fourth year, you're taking higher level technical electives and focusing on your capstone design project, which is a chance for you to really demonstrate and showcase everything you've learned up to that point through a project that involves a real world engineering problem. So in terms of the workload, I like to tell students that engineering education really is a full-time job. And to demonstrate that, I'll use kind of a typical work term with 5 courses. So if you have 5 courses, each course has 3 hours of lectures per week. So 5 courses, that's 15 hours of lectures per week. This is basically the professor teaching you the material, introducing new concepts. And And each course has, in addition to lectures, each course has 1 hour tutorial every week. A tutorial is kind of like a review session where we'll go over the concepts that were introduced in the lecture, maybe do some more example problems, help you really digest that material. In addition, depending on what courses you have in the term, you may also have labs, which typically take 2 to 4 hours per week. So in total, in terms of class hours, you can expect about 20 to 24 hours of in-class time. This is time you spend interacting with the teaching team, 20 to 24 hours per week. In addition to the in-class hours, a typical student will spend about another 2 to 3 hours per day studying or completing assignments. So that's about 10 to 15 hours per week. This is what an average student would put in. So altogether, you can an average student will require about 30 to 40 hours of study time and class time per week. And upon graduation, our students find careers in a wide range of different areas. And so this is just an example of some of the areas our graduates work in. And this includes planning, management, structural design, and even architectural conservation. Because our academic and co-op program are so well developed and respected by our employers, our graduates are always in high demand, and our students generally have no problems quickly finding jobs upon graduation. And of course, at the end of your undergraduate degree, if you want to gain more depth, or if you want to further develop your specialization, graduate studies is always an option. So our program, as you can see, is quite rigorous. If it wasn't, if we would all just be average engineers, we don't produce average engineers at Waterloo. But given in all its rigor, we have lots of resources to really help you succeed. At the faculty and department level, we have many award-winning faculty members, instructors, lecturers, and researchers to help you learn the material and get real-world experience. They're distinguished teachers with excellent track records in both teaching and research. And when you come here and you start in first year, we'll have a dedicated teaching team for first year students. They're professors and support staff who will help you really transition into the university learning environment. And they'll help you develop the proper study skills and time management skills that you're going to need to really succeed here. And really, and to help you really enjoy your time here at UW as well. In addition to faculty support, we have student societies like CGIS, Civil, Environmental, Architectural, and Geological Engineering Society, and also the Waterloo Engineering Society. And these are student-run societies that help students in a variety of different ways, finding jobs, promoting student wellness, promoting equality, diversity, inclusion among students, things like that. And these societies really help bridge any gaps between students and faculty members. And they're really here to help you get the best possible student experience. And so down the road, if you're interested, these societies are excellent opportunities for you to take on more of a leadership role and help other students as well. So in addition to our academic requirements, our academic program, experiential learning is such a big part of our curriculum and who we are. And we strongly believe that to develop engineers who excel at problem solving, you have to combine theory and practice. So this is kind of our approach to engineering education. And so we have lots of hands-on activities and labs. We have so to help students really see and feel and really apply theory that they learn in classrooms to real-world problems. And in addition to in-class activities, we also have lots of design teams, student design teams that students can join to really compete and showcase their engineering skills. And teams like the Concrete Toboggan and the Concrete Canoe teams, these student teams compete in competitions at both the national and international stages. So students have not only gain hands-on experience, they have fun doing it. In recent years, we've also incorporated what we call design days into our curriculum as well, to help students gain that hands-on experience and expose them to engineering design at an early stage. So civil engineering students in second year will basically tackle a full-on bridge design problem, starting with the conceptualization, design, cost estimates, fabrication, and ultimately testing the bridge by loading it. And it really helps students see engineering problems, real-world engineering problems, test their problem-solving skills, and tackle projects as they would in real life. And it helps students not only get a feel for what tackling an engineering problem is like, but it challenges them to be creative and resourceful, qualities that engineers really need to tackle problems. Students really have fun with this project every year, and faculty members were always impressed by what students are able to come up with. Of course, what differentiates our program here at UW, and a big part of our experiential learning, is our co-op program. In terms of co-op, there are many possibilities, many different possibilities when it comes to co-op jobs. And most students will typically cycle through a wide range of engineering jobs in different working environments and gain experience in many different areas. And the best part of co-op is that your co-op experience counts towards your professional engineering license, the experience requirement for obtaining your professional engineering license. So these are some examples of jobs that our students find for their co-op terms. The first couple of co-op terms where you maybe don't have the experience or you're not that far into your academic program, students will typically find more entry-level positions involving drafting or surveying or estimating. But as you gain more experience through more co-op terms, and as you get further into the program, students move on to more engineering duties like field or lab testing, design, and field inspections, etc. As I briefly mentioned earlier, so every student, there's a total of 6 co-op work terms. For civil engineering students on stream 8, your first co-op term comes after you finish first year. And out of the 6 co-op work terms, students must complete at least 5 of them in order to graduate. And as you can see, in terms of employment rate, with the exception of your very first work term, the employment rate in general is almost 100%. So most of our students have no problems finding a co-op job. In first year, your very first work term, as you can kind of imagine, can be a little bit challenging just because again, you don't have that experience and you're only a year into your academic program. But I'll talk a little bit about helping how help is available to help you find that very first co-op job in a second. In terms of course, a big part of co-op is that we get paid. And by the time you're in your 5th or 6th co-op work terms, students are typically making about $25, $26 per hour on their co-op terms, in addition to gaining valuable, really engineering experience. So finding that very first co-op job can be quite challenging. So what can you do to maximize your chance of landing that first job? A couple of things. You can start with a part-time job or a summer job, or maybe you can volunteer a little bit and do things that really show that you're committed, you're dedicated, and that you make a good employee. And there are also, as a department, things that we do to help students. First, we try to help students have the basic skills that employees are looking for. So we teach first year students surveying, some AutoCAD, and also we get students into technical writing. And also we have lots of resources at the department level and at the student level as well, with resume writing and taking interviews. So in the end, it really is our students that give us our reputation as one of the best engineering schools in Canada and in the world. So that's basically an overview of the civil engineering program. Again, unfortunately, our student representative couldn't be here to talk about the student experience, but hopefully these last few slides give you a good snapshot of what civil engineering students go through in our program. So thank you very much. I hope to see you all here in the fall.